All right, thank you all for joining us today, this morning/afternoon for everyone in Ireland. I'm very excited to announce our second webinar session collaborated with BiOrbic and CINDE's Biomaterials Hub. We have an exciting session today. I'll just run through the agenda for you. So we've got an introduction to BiOrbic. We have a discussion around food waste valorization by Dr. Ajay Menon. We have a talk about IP and technology transfer soon after, followed by life cycle assessment in agroforestry, and then mobile biorefineries, followed by two speakers from Costa Rica talking about the state of the industry and the academic industrial collaboration aspect in Costa Rica. My name is Adam Day. I'll be your host today. I'm the scientific lead for the Biomaterials Hub here in Costa Rica, run by CINDE. And I'll give you a quick overlap and overview as to what we do and what we've done in the last 2 years that we've been active. So the Biomaterials Hub is an institution or an entity developed by CINDE as the executing partner and funded majoritively by BidLab. We're an entity or an initiative focused on developing biodiversity related and biomaterials related opportunities in the country. And we did this by providing services to different companies based in Costa Rica, from early stage entrepreneurs all the way to large MNCs. And we also try to identify the research, development, and innovation needs of different companies, different actors within this ecosystem in order to support them, in order to kind of help them grow. It could be anything from helping researchers collaborate with industry, researchers collaborate with other researchers, both locally and internationally, as we are aiming to do with this collaboration with BiOrbic. We have 4 key value propositions. Firstly, of course, biomaterials, especially in Latin America, is still quite a niche field. So we're trying to build up the awareness, build up the capacity in biomaterials, set up training programs, setting up webinars, workshops with urban and rural communities. We're also trying to identify the needs and requirements of the industry and how we can connect research and development to their needs and kind of do it in a bilateral system. We also, and we have done in the past, by providing financial and non-financial support to different startups and different collaborative initiatives within the country. And very importantly, because of how niche and how small Costa Rica is, it's important that we have a lot of national and international alliances. So we've been developing a lot of these connections and collaborations with various entities such as BiOrbic to promote translational R&D, to promote awareness building, and to promote joint access to resources. Costa Rica is an amazing and very fruitful place for an ecosystem of biomaterials to grow. Costa Rica has very strong infrastructure, both from the academic and the private sector side. There's a huge amount of natural resources available, with more than 5% of the world's biodiversity in such a small landmass. There's a lot of ancestral knowledge when it comes to natural products and natural resources. And as we all know, Costa Rica has an immense agricultural sector. I think, well, most of the world's pineapples come from Costa Rica. So that not only means there's a lot of agricultural development, but there's also a lot of agricultural biomass available in Costa Rica that is ripe for valorization. And of course, Costa Rica's one of Costa Rica's big selling points is its commitment to sustainability, from an energy perspective, from a national park perspective, and from its biodiversity perspective. So all of these different parameters make Costa Rica a really valuable hub for biomaterials in this case. And just very quick last slide, just an overview of what we've done. We've been working on different projects and initiatives, and over the last 2 years, or slightly under 2 years, we've had various amounts of different companies accelerated. We've had startups and entrepreneurs incubated. We're currently setting up innovation challenges with large MNCs and large companies. We've trained over 400 people through different various methods, through incubation programs, innovation programs, workshops, seminars. And we've also, and very importantly, built up a pipeline of very interesting projects based in Costa Rica, from researchers to entrepreneurs in a lot of novel and interesting areas such as synthetic skin, biopackaging, bioplastics, construction or alternative construction materials. And we want to see this continue. So we have a lot of next steps for the Biomaterials Hub. And one of the most important ones is working with UNDP, or its Biodiversity Finance Initiative arm, BioFin, in order to identify financing mechanisms for biomaterials related businesses and development. So this project and this initiative is currently ongoing, where they're doing a pre-feasibility assessment, and then the next step is to understand and identify potential investors that could be involved in this field of biodiversity and biomaterials. We're also setting up, we're just going to be launching in the next couple of weeks, an R&D call focused on taking TRL 2 to 4 projects up to 4 to 6 plus. So this is focused on scaling up from lab scale validation, and kind of taking it to the next step in terms of business development and technical development. So for all you, let's say, entrepreneurs or companies that are here in the audience, it would be great to just get your perspective and keep an eye out for this R&D call that we have launching soon. We're also activating a scientific committee in the next few days in order to, let's say, strengthen the ecosystem, the academic ecosystem in Costa Rica around biomaterials, and provide and foster a lot more collaborative resource sharing and collaborative project development. And finally, we're also focusing on R&D and I capacities for the biomedical and the medical device sector, because this is also an important part for biomaterials, but it's not the only part. The agricultural, the food waste valorization, the biomass valorization, new biomaterial opportunities for construction and automotive is also very interesting to us and very important. So we're keeping our definition of biomaterials quite broad in this case. Now, with that said, I'll stop talking and I'll pass the mic on to Sean Douglas, who will be giving an introduction to BiOrbic, and then we can start with some of the very interesting talks.
Thanks, Adim. That's great. Hi, everyone. Good morning, good afternoon, depending on where you're joining us from. So delighted to be part of this second webinar. Lovely to meet you all, albeit virtually. So I think during the course of the webinar, we're going to be discussing sustainability research, using Ireland kind of as a test case. Personally, I think Europe sees Ireland as this small country that's a good little test bed for things that can scale to Europe and beyond, and also to see how Ireland and Costa Rica may work together on our joint sustainability journeys in the future. So we hope you find our, I'm sure you'll find our presentations from our researchers interesting, and they'll share their success stories on their kind of research journey on collaborative research projects with industry. So I'll discuss kind of the structure of BiOrbic, and my colleague Stacey Kelly will discuss kind of the technology transfer structure in Ireland, and really how that enables best practice to scale the impacts from our research to the companies and to the economy and society overall. So I'm sure there'll be lots of interesting discussions as part of this webinar. I think the last time we did it, Adim, please feel free to post kind of questions in the chat during presentations, and we'll get to the questions at the end. I think there'll be great kind of thought-provoking discussions today, opening up potential opportunities for partnerships between us. So Lovely to meet you all again, and I'll just go onto my slide deck here to just describe BiOrbic and its structure in a little bit more detail. So is that okay? Can you see that all right?
Yeah.
Great. So BiOrbic, it's just a short kind of introduction. Really, our vision overall, we have a research program to 2030, and what we're looking to do is to aid in the transition to a climate neutral bioeconomy that's circular, that's sustainable. So to our second phase of research, called phase 2, is from now until right to the end of 2029, 2030. So as we know, globally, 2030, there's enormous targets. So all our research is kind of with that vision in mind. It's not a bad idea having those targets, they're great, but trying to backcast from that and to see, okay, how can our research have impact in order to achieve those climate targets? So just a little bit about BiOrbic. It's one of 16 research centres in Ireland, funded by the Irish government through Science Foundation Ireland, covering really a whole range of topics. BiOrbic looks at renewable biological resources, so typically the agri-food, forestry and marine sectors. Increasingly, we're getting contact from companies looking at materials, biomaterials, biopackaging. So it's really a really kind of a sector that's ripe for disruption. So our network is national and international. So we have a national footprint. We collaborate across all the universities in Ireland. We've extensive collaborations internationally also. Our researchers, we've over 100 researchers nationally. So in describing our expertise, we have deep domain expertise, physics, biology, chemistry. We've sectoral experts in the marine, forestry, and agri-food sectors, as I mentioned. Then we have supply chain, biodiversity experts, then the social sciences as well as life cycle analysis. So, as I mentioned, we're Ireland's national Bioeconomy Research Centre, and we do research projects, as Adeem mentioned there. We have fundamental research, which is typically lower TRL, looking at the really hard to tackle challenges that aren't as close to market, but they're very, very important. And then we have applied research that, as Adeem called it, translational R&D. So really, we're looking to solve close to market pain points for industry. So companies engage with us, our experts. We can do targeted projects that are 100% funded, and we can provide co-funding for targeted projects as well, leveraging its impact. And in engaging with us, the companies have access to both our networks and also facilities as well. In terms of collaboration, companies want to maximize the impact of their R&D. And then looking at the sustainability of production. And then all of this looks at improving the sustainability profile. And typically that goes hand in hand with improving the financial performance of a company. You've less waste, you've less emissions, and very often you can turn what is typically a cost into something that you can valorize and upcycle and generate more value in your company. Just some examples of kind of flagship projects that we have. So you'll hear from Ajay and Jim today. We look to tackle the big societal challenges. So more recently, we're taking that kind of challenge-based approach to our research. So whether it's tackling food waste and looking at how do we take that food waste. In Ireland, there's over 1 million tons of food waste annually. How do we take it? And it's only a waste if we can't upcycle it and use it. So how do we take that waste and convert it into higher value products? Also, there's an issue with food waste and the packaging that it comes in. So how do we look at valorizing that tricky problem to solve? Also, we're looking at direct decarbonization, in this case on the world's first carbon neutral dairy farm. So we're on the way to being carbon neutral. I believe we're aiming to be carbon neutral on that farm by 2027. So these are typically sectors that are very hard to get to climate neutral. You know, looking at adding value. So we really have kind of access to the network. We play a kind of heavy role in policy within Ireland in shaping kind of the bioeconomy and sustainability policy, as well as kind of, as Adeem mentioned as well, running events, workshops, raising awareness of the services that we offer. So as I mentioned, our phase 1 is just completed. So BiOrbic, we're 6 years old. We're like a startup, really. So the next phase is going to be right to the end of 2029. Just very, very briefly, as I mentioned, our research in phase 2 is going to take more of a challenge-based approach. So that spans across 5 pillars and 17 research challenges. So I won't go into all of the details here, but just to give an idea, you know, we're looking at the vision at the top, and the pillars are really how do we structure our research to achieve that vision. So we have to have healthy ecosystems at the end. We're looking at the operational systems of the forestry, marine, and agriculture. You know, as much as we try, those sectors are going to produce waste. So how can we use that waste to upcycle it and valorize it into higher value products? And then we look at the bioeconomy as a system, making it more circular, looking at bioenergy to power. There's no point doing all this great research if we're still using non-renewable polluting fossil fuels. And then the enabling action will be life cycle analysis, the social side of the transition, ensuring that it truly is a just transition for all the actors and stakeholders. So, look, that's a brief, very brief kind of whistle-stop tour of BiOrbic itself and just its structure. So, thanks very much and welcome again. Delighted to be here, and I'll hand back to you, Adeem, and we can go on to the researchers' presentations.
All right, thanks for the introduction, Sean. I mean, before we get started, I just want to let everyone know and let the panelists know that we will have 15 minutes for the speaking session, followed by 5 minutes for Q&A. And as Sean had said, you could put the questions directly into the chat or the Q&A function on the Zoom platform, and I'll be moderating and making sure that the questions are asked and answered. I'll be giving a 2-minute warning to all speakers before the 15 minutes are up. And yeah, I think we can get started. So our first presenter for today is Dr. Ajay Menon, talking about food waste valorization. All yours.
Yep. Hello, everyone. Let me just start my presentation over here. Can everyone see that?
We can see your desktop. Oh, no, now we can see it. All good.
Okay. Maybe there is a couple of seconds of delay. So yeah, hello, everyone. Just to introduce myself, I'm Ajay Menon. I started out in BiOrbic in 2019 as a postdoc. And just recently, last month, I have joined UCD as an assistant professor, as a faculty over here. So initially, I've been working. Is my voice coming through? Is everything fine? Okay, perfect. Okay, so I've been working ever since I joined BiOrbic under Professor James Ling, who's over here as well as a panelist. So he's a lead on most of the work that I'm doing, which I'll be going through. It'll be a whistle-stop tour as well, just like Sean. So I'll rush through some of the technologies that we have been working with, the kind of solutions that we're developing, and I'll talk a bit about 2 projects that are going on that focus specifically on food waste and food waste utilization, food waste valorization, and so on. both of which heavily are about working with the private sector and with companies that are actually in the waste management business in Ireland and coming up with solutions for improving their operations. So just to introduce you to our core team as such. So like I said, Professor Ling is the lead PI on most of these studies, most of these projects that we do. His expertise is in developing novel processing techniques. He was initially in the food science, food technology sector, and is slowly moving into the circular economy, sustainability kind of research. That's me. My background is mostly developing bioprocesses, working with renewables, working on waste management and such, with a very heavy focus on aromatic digestion and microbial fermentation. Sorry. And we are now working with Norman Maloney, who is a new addition to our team. He has 30 decades of experience in developing technologies, taking them from the drawing board straight to all the way to applications, scale up, and developing products that are actually used in the market. So we have three kind of prongs of research focuses in our group. The first is working with emerging food processing and bioprocessing technologies, developing novel technologies, looking at their application. The second is applying them very specifically for developing sustainable food or bioprocessing, which is essentially looking at sustainable alternatives to the conventional ways in which bioprocessing is done. And the third is applying these technologies, applying the products for looking at value generation from waste valorization, looking at of producing bioenergy or renewable gases like biogas, hydrogen, and so on, by the application of these novel technologies and novel processing techniques. And lately, we are specifically looking at anaerobic digestion and biorefineries as solutions for the transformation of food waste into energy and into novel products by using these novel processing interventions. Our work is done very much within the framework of the Sustainable Development Goals. We kind of base our thinking or conceptualization of solutions of using the framework and using the targets that are already being identified. So our big focus is on SDG 7, SDG 11, which is about clean, affordable energy, sustainable communities. And the main kind of target that we are looking that we are working towards is just creating solutions for responsible consumption and production of food, of using waste that comes from food production. And well, that's kind of the direction that we are trying to head to. So when I talk about emerging technologies, it's two main types of emerging technologies that we work towards. These are pulse electric fields, ultrasound. Pulse electric fields, it's application of like very short pulses of very high energy electric currents directly to various biomasses. Could be foods, could be food waste, could be any kind of organic matter that can actually conduct electricity. Ultrasound, UV light, any high energy light beams, which I guess is kind of self-explanatory. Moderate electric fields, which is kind of like pulse electric fields, but electric fields of slightly lower energy than other longer wavelength electromagnetic treatments like radio frequency, microwave as well. So the two types over here are the first three are what's called non-thermal electric fields, technologies, where the impact is carried through various different mechanisms like electroporation, cavitation, breaking down of DNA, and so on, that doesn't generate electricity. And the other two basically alternative ways of heating products that's more sustainable, uses more resources, and so on. And there's a huge it's kind of, we call it novel technologies because there wasn't really much research, as you can see, done here till around 2000, 2005, and suddenly there's a huge uptick in the kind of research that you see published. So it's a very new field, and we are kind of excited to see all the applications that we can come to. So this is a word cloud of the various impacts that you see in literature using these kind of novel technologies. So a lot of it is extraction, green processing, food valorization, microbial inactivation is a big one. A lot of these technologies are uh, more sustainable alternatives to the regular pasteurization method that are used for microbial inactivation, for both for wastes, for creating novel foods and so on. So that is kind of the research direction that we are heading to with these technologies, most of which that the lab, Professor Ling's lab has been working on since the 90s. Like I said, a lot of the lab efforts over here have been to take these novel processing technologies and then head into sustainable processing. So again, the focus over here is the reduction of energy that goes into processing, reducing water consumption, which is another a big SDG that it used to be an SDG. Now it's kind of becoming it has a lot of economic impact as well. So that's another, there's a lot of economic policy drivers that are improving, the prospects of the applications of these technologies in the industry. The big one is recycling of byproducts that come out of food processing, food production, agriculture, and converting the byproducts, converting wastes into value by biorefinery, by anaerobic digestion, by microbial fermentation, and so on. And finally, just ensuring high quality, safe products by things like microbial inactivation that I just mentioned. So the emerging focus is for our group is waste valorization, particularly waste valorization of food waste, because I think, like Sean mentioned, food waste is one of the biggest contributors to global warming, to climate change, because of it accounts for like 8% of the total greenhouse gas emissions. It's also just a huge uh, process inefficiency. Like a lot of you're wasting a lot of resources that are put into the production of food. A third of food that's produced is wasted. So that is the energy and the value that we are trying to recover. And a very mature technology of recovering that value is anaerobic digestion. Now, just to give a very brief introduction to it, anaerobic digestion is essentially using bacteria that work in the absence of oxygen to to break down the substrates. This could be energy crops, it could be food waste, it could be wastewater, like any kind of organics that can be broken down by bacteria to its monomer constituents like lipids, carbohydrates, proteins. These are then converted by a very complex consortia through various metabolic intermediates, and finally into biomethane and into biomethane and biohydrogen. Both of these can be used as renewable as fossil fuel alternatives. And since you can use crops or you can use wastes to create these fuels, it counts as a renewable fuel or renewable energy. So it's a fairly mature technology. There's an already strong existing anaerobic digestion industry in Europe, in Asia, in the Americas as well. But in the last few years, the button has really been pushed on this technology, on anaerobic digestion. And we are seeing the establishment of tens of thousands of new AD plants across Europe, which comes with its own issues and its own demands, but it presents a very great solution for the creation of circular economy, because it takes in wastes that come right at the end of the life cycle of the food production or the agriculture system. And by converting that into energy, by converting that into stuff like biofertilizers, you put the value right back into the system, and the whole process can be converted into a truly circular process. So the way it's carried out is generally, conventionally, the way it's done is anaerobic digesters are black boxes. What is done is organic wastes are put into it with very bare minimum processing. What comes out of it is biogas, which is converted into heat or electricity, and around 70 to 80% of what you put in comes out as digestate. This digestate has to be legally pasteurized before it can be used as biofertilizer or added back to the soil to increase soil quality and so on. And that represents a huge cost on, so basically 30% of the biogas or the energy that is generated from biogas has to be diverted for the treatment of digestate. And this kind of leads to a very the cost benefit of anaerobic digestion isn't that great because of this parasitic cost. So that is what we are trying to solve over here by having pre-processing interventions that first of all upgrade the kind of substrate that is put into the anaerobic digester, and then post-processing interventions that economically turn the digestate into something that can be used for electricity, for fertilizer, for materials, and so on. So we have two major two projects that we have been that we have carried out. So the first is the VAVA project. That was all about creating solutions for anaerobic digestion for horticulture and for microbial photobioreactors by connecting the whole process together. This was done by creating unique electroprocessing solutions that, like I said, upgrade the food waste that goes in, creates solutions for safe dewatered effluent economically. And then the biogas that was generated, we removed the carbon dioxide from the biogas, as well as the water was recovered from the dewatered digestate of the effluent, and it was used to grow microbial microalgae in photobioreactors that basically were novel foods. So that was a good example of using food waste as a driver for the circular economy using novel processing techniques that we have been developing in our group. The second project that we've been working on is, this has been recently initiated. It's called Bioeconomy. It's a commercialization project for the processing technologies that were developed as a part of VAVA around anaerobic digestion. So over here, we are trying to solve the key pain points of the anaerobic digestion industry, that is suboptimal feedstocks, operational inefficiency due to the parasitic load that I just mentioned, and then improving the leads as well, improving the yields of anaerobic digestion, just improving the amount of biogas that you get from the food waste that you put in. We are working with 3 trial partners over here. FSM, it's a major waste processing business in Ireland. They supply mostly to anaerobic digestion plants. They want to increase their food value. They want to become a tech provider to AD plants across the EU. Green Generation is a major AD plant that is situated at Ireland's main biomethane injection point that's connected to the Europe-wide grid. So they are looking at adding new feedstocks and improving their bioavailability. Again, their focus is food waste as well a little bit. And they want better heating and pasteurizing solutions, as the current technology really doesn't work for them. And Biocore is a large AD company that is already operating different plants around the UK and Ireland, and they're seeking to build new plants. But again, for them, the bottleneck is the quality of the waste that goes into the plants and the heating technology.
2 minutes left, Ajay.
Yep. I think I'm just 2 slides away. So what we have done for them is use our technology to basically give them 2 scenarios that solve these problems. First is we use our technology to disrupt the feedstock, increase its bioavailability. That goes before, like prior to the anaerobic digestion, and then post digestion, we use our technologies for carrying out the pasteurization very effectively. The other is we front load the entire pasteurization process. So we remove the capital cost that is associated with the pasteurization, and we do both the feedstock disruption and the pasteurization of the food waste that goes into the anaerobic digester. And then at the end, you get a fertilizer that you can use safely. So what the value proposition for what we do is we increase the biogas production by up to 30%, and we can decrease the parasitic load by up to 30%. So this is basically how the technology works. It's a pipeline solution. The electric fields are applied as the substrate flows through the pipeline. So there's very little change to the actual operations of all these partners. And so the benefit for them is for FSM, it really improves the value of their product, which is essentially upgraded food waste for green generation. It increases the energy revenue that they generate by the digestion of food waste and other organic wastes and converting it into biogas. And for Biocore, it reduces the payback time to 3.8 years from 5 years. So that's how we have been working with all these trial partners and developing our relationships. So just a little bit of an example of how these partnerships have been developed. So Adam Lord was the first major industry partner that we had. Our partnership with him started in the Wawa, the first project that I mentioned, where he was a sort of a societal impact champion for looking at how food waste can be used for different methods. Because we were able to carry out economic assessment and financial modeling using his business models, he was very impressed with the kind of value that we can generate for him. So that's how we came into our current partnership, where he's a major trial partner for the commercialization technology, for the commercialization project that we're working on. The partnership terms were spelled out, mediated by the UCTTO, by Stacey Kelly, who would be speaking later. So maybe she can shed light on how that was done from her end. And in the future, we'll be demonstrating our technology at a pilot scale at his facilities. And he's expressed interest in licensing the technology or even being a partner when we actually enter the market, the technology. So I don't think I need to go into all of this today. That's essentially the kind of work that we do. It goes across the whole breadth of food waste utilization, food waste reduction, food waste recycling, and just transforming the food waste back into value, putting it back into the bioeconomy, and creating novel products, novel technologies through the entire research platform. And that's really it for me. Hope that came across clearly. These are our contact or emails. We are very happy. We're always looking for collaborations around this area: novel technologies, utilization of food waste, valorization of any kind of wastes, really, and creating value from them. So that's it for me.
Thank you, Ajay. Let's kick off with some questions. So I've got some questions from my end.
Yeah.
What are the major challenges with implementing this in a large scale within industry?
It's kind of, it really depends on, sorry, let me just stop sharing first. It really depends on the kind of industry that we work with. So we work with 2-3 different segments of the industry. We work with food producers, we work with food waste producers, with food waste utilizers, and so on. All of them, I'd say the very common issue that all of them have is the landscape right now is changing very quickly. So the last couple of years, the big driver was the energy prices that were really surging. So the kind of solutions that they were looking for was things that could reduce their energy intake, or for the companies that were involved in energy production, like green generation or bioco, their focus was how can they increase biogas production, because suddenly that went from something that was a good to have technology to a must have technology. If you understand what I mean, the product suddenly became very valuable. Then later on, when those prices kind of stabilized, the new push was then energy reliance, energy resilience, because of the war in Ukraine and all the issues that came with it. There are now huge policy drivers for just implementing all these kinds of waste valorization activities, for creating renewable energy and so on. So a big issue has been just figuring out what pain point to really target at what time. The other thing is just uh, identifying the pain points itself, because researchers sometimes go in with a very set notion of things that they might think are the pain points for the industry, which might not be the case. The industry might have some pain points that we are not really that aware of. So you really need to develop very strong relationships with these kind of stakeholders, really talk to them, get to know them, figure out what they want, why they want certain solutions, what kind of time scales that they're working on, and then really communicating the value proposition to them properly. Because sometimes we talk in very different languages, where as scientists we talk in the kind of research value that we can generate. For the industry, the answer is always, they're always looking for the bottom line, how much, what kind of money that they're putting in, and what return they're getting for the money. So I guess that's the big issue. And I, am I really answering that question? Was that
No, that's good. I have a question from the audience, and this is more general. So the question is, how can the researchers from our university join in new projects in the future for collaborative work?
Well, what I would really recommend, what really worked for us, is speaking with your university TTO. They really have a good handle on the kinds of opportunities that are out there, either through research grants that are funded by the government, or international collaborations that are going on, or even they might be speaking to people from the industry, or investors that are on the lookout for solutions or collaborations and so on. That I would say that's the first person you speak to. The other thing is,
I think this is more focused on how can they collaborate with you and your kinds of new projects, with your projects that come up.
So I would say speak with the people, the core team at BiOrbic. We have a very like Sean had just mentioned the framework. Yeah, I think Sean can take this. He's a better person to answer this.
Yeah, no, I think just to echo what you said, Ajay, just send an email, and just email me, and Adim can put the email address at the end, and we'll go from there. There's a few kind of research funding calls. We have a full-time, actually 2 full-time people that look at the international and national funding calls for research. So there's one that's an open call at the moment. I think it's called the Suez call. It's €100,000. So there's always kind of funding streams that come up, and we have kind of staff that kind of are, I suppose, keeping track of that. But by all means, email me. I'll be happy to discuss further.
All right, excellent. Now, in the spirit of time, I think we'd like to move on to our next speaker. So we have Stacey Kelly here talking about basically what Ajay was mentioning at the end, talking about TTOs and how technology transfer would be important to set up these sort of collaborative projects. Stacey, the floor is yours.
Perfect. Can everyone hear me? I'm having issues with my video at the moment, unfortunately.
No, we can hear you fine.
Perfect. I'll just share my screen. Everybody see that?
Yes.
Perfect. So my name is Stacey Kelly. I work in the Technology Transfer Office in UCD, and I specifically work with researchers and company in the food, veterinary and agriculture space. So I'll just give you basically a whistle-stop tour in terms of UCD, Nova UCD, which is where I'm based, and it's a centre for new ventures and entrepreneurs. Just to give you an idea of some of the success stories that we've had, and then a brief introduction in terms of the knowledge transfer, tech transfer ecosystem in Ireland. So just to give you kind of a snapshot of UCD. So it's Ireland's largest university. It represents the top 1% in QS rankings. We have about 35,000 students from 152 countries, so we're Ireland's leading global university. And we have 1,200 academics plus drive to recruit 500 further. Research expenditure of about 100 million per year. And then the research awards that we had took in last year amounted to 156 million. We collaborate with over 2,500 industry partners. And we've had 32 startups and 15 HPSUs in the last 6 years. And 25% of Ireland's university startups were from UCD in 2022. So Nova UCD, as I mentioned, this is our Centre for New Ventures and Entrepreneurs. It was set up in 2003, and it's basically a facility where our Technology Transfer Office is based.
Stacey, we're looking at your presenter view.
Oh, sorry.
Yeah, that's perfect, Stacey.
You see, okay.
Perfect, yeah, we can see it perfect now.
Perfect. We were repurposed in 2003. It's our incubation facility. So we're made up of spin-in companies. That's companies where the IP has not come from the university, but which the companies want to be based next to the university to basically be able to collaborate and work with our researchers, and also to get opportunities in terms of linking in with our students. We also have our spin-out companies. So those are companies that have been based on the intellectual property developed in the university, and they want to be based next to the university ecosystem. So we have, since our establishment, we've had over 1,100 inventions disclosed to us. We've had over 1.1 billion equity funding raised. We've supported over 500 companies in new ventures, and we have spun out over 60 companies. So just to give you an idea of the national funding ecosystem and the number of national funding bodies that support commercialization and industry engagement within Ireland. So as you're aware, BiOrbic is funded by Science Foundation Ireland. BiOrbic is one of many research centres which are focused around a specific topic. And it really is to build the societal and economic impact in a particular domain. So BiOrbic is focused on the bioeconomy with a number of research centres that are hosted within UCD, but which we link in with a number of the national research performing organisations and with industry. So iForm is based on manufacturing. iCrag is based on the geoscience space. We've Vista that looks at the ag tech space, and then Insight, which is data analytics. SFI also funds a number of different initiatives such as the industry R&D+i, and this enables postdocs to basically work with industry for a certain period of time. It's kind of a training program. And then we have the national, the SFI Challenge Awards, and this is where certain challenges are identified. And there's researchers come together and work with societal champions to bring that to the fore. Another key funder that we have in Ireland is Enterprise Ireland, and these really support national SME and multinational companies, but they also have a strong R&D component, and the idea is to bring research from the university out to the marketplace. So like SFI with the research centres, Enterprise Ireland funds a number of technology centres, and again they have a specific focus on a certain domain. So we've Food for Health Ireland, which looks at functional food. We have a dairy processing technology centre, and CINDE, which is again looking at data analytics. And these centres, like the research centres, are to bring the research performing organisation in collaboration with industry to solve industry problems. As I mentioned, the commercialisation fund. This is a fund that specifically, it's specifically awarded to projects where the idea is to spin out the company into an actual legal entity in its own right. So this funding is awarded for projects that have a real commercial potential. So there's a real market push for a spin out company, and the idea is that within a period of about 2 years, that they have the sufficient technology development and commercial development to form a business plan, engage a CEO, raise investment, and form a spin-out company. Another funding mechanism that Enterprise Ireland funds is an innovation partnership program, and this is a co-funded program. So this is where industry comes to UCD with a specific problem to solve, and Enterprise Ireland will part fund that, and the company part funds it. And there's a number of other funding mechanisms, which is Career Fit and the Disruptive Technology Innovation Fund. And we also have the Irish Research Council that look at training, and that's enabling masters, PhDs and postdocs to work with industry. And the Department of Ag is another funding body that also works to encourage research that has kind of a market potential and societal impact. So just to kind of, I suppose, focus on some recent success stories. So we've had Provi, so Nick Holden, which is a member of the BiOrbic team, himself and his colleague, Jerome O'Connell, spun out a company back in 2019, looking at remote sensing using an image analysis technology, and they recently raised 1 million investment. We also have a company, Air Therapeutics. This is a collaboration between UCD and UCSF. It recently spun out and raised 32.5 million in Series A funding to develop a novel drug to help those suffering respiratory diseases. And then we have O'Casey, so again, another BiOrbic researcher. He spun out the company Oxymem, and they were acquired by DuPont in 2020. So just an idea of some of the successful spin-outs we've had. And I suppose one of the kind of the key state agency that brings industry and the research performing organisation together is this Knowledge Transfer Ireland. So it was established back in 2014, and its role is really to encourage business to engage with and leverage the research that comes out from the universities. And it basically forms a framework to help and to streamline the process. So it manages the funding programme to support the Irish tech transfer function with Ireland. And the objective is to sustain and develop appropriate skills within the TT offices for the management and commercialisation of IP. So it's been a funding mechanism that's been around since 2007. There's been various different funding tranches, and the recent KT Boost is a co-funded model between the government and the European Union to the European Commission to fund another 4 years of that tech transfer initiative. So the principles, I suppose, that guide the IP management within Ireland is set by this national IP protocol. And I know, even talking to colleagues in other jurisdictions, they say it's a really useful framework because it basically sets down the guidelines for which IP is managed in co-funded projects with industry. And as part of Knowledge Transfer Ireland, they've brought about this framework. It has had a number of revisions, but they've also put together a number of model agreements. What are these? These are model collaboration agreements, license agreements, material transfer agreements. They're based on best practice. They've had input from both the universities, Irish solicitors, and industry. And it makes working with industry much more streamlined because we can actually point to model agreements that have had, I suppose, all stakeholder engagement as part of it. Another thing that Knowledge Transfer Ireland has developed are a number of practical guides. These are for researchers and for companies to be able to be aware of simple things like, say, confidentiality agreements and when to put them in place, intellectual property, what it is, and licensing, the reasons why certain provisions are put in place. And just supposed to give a role in terms of technology transfer offices, these are based in each of the research performing organisations in Ireland. We manage and commercialise the research, the IP that comes out of the university. We're involved in a number of different areas such as IP contract negotiation, developing an IP strategy. So say I would have worked with Ajay, Norman and Jim at the beginning of the commercialisation fund to put together that commercial opportunity to put in the funding grant, and I continue to work with them throughout the process to make sure the various contracts are in place, but also to manage the IP that comes out of the project. We work to develop this commercialisation strategy, provide supports to develop IP for commercialisation. We license to industry. We also are involved in industry engagement and the creation of companies. And we have our own UCD IP policy in addition to the KTI framework. And just, I suppose, in terms of to give you top level metrics. So every year there's Knowledge Transfer Ireland produces this report. And this just gives you an idea in terms of the amount of outputs that comes from the Irish ecosystem. So back in 2021, there was 486 new inventions disclosed. Just give you a snapshot, there was over 217 LOAs signed, 27 new products was put on the marketplace, and there was 32 new spin-out companies that was spun out. And I suppose just to end, so Ireland has this 2030, Ireland's Impact 2030 is Ireland's research and innovation strategy. It's launched in May 2022, and basically it puts research and innovation at the heart of addressing Ireland's social, economic and environmental challenges. So hopefully I've answered any questions, or I've addressed any queries you may have.
Thanks, Stacey. That was really insightful and great for Ireland and great for the innovation ecosystem, basically all the results that you've shared. I had one question specifically about spin-in. Costa Rica has a lot of infrastructure, a lot of value that could be generated from universities, and there are a lot of entrepreneurs that are independent. Now, how has Ireland done this in terms of spin-in, and what are the, let's say, the fair terms of an IP policy with spin-in companies?
So Adam, in terms of that, a spinning company, when they're based in UCD, they're seen as a separate legal entity. So they would be treated the same way as any industry partner would. It would be in compliance with that national IP protocol. And that sets the guidelines, irrespective of whether it's a spin-in or it's a small and medium enterprise. So the IP would be the same.
Okay, great. Well, we have one question basically asking about if they can get a copy of the presentation. So I guess
yes.
It's yeah. Any other questions? Anyone from the panel? Give them a couple of seconds.
Either I've explained it completely or I've confused everybody.
I have another question. So what happens when it comes to international IP agreements with other countries? Do you still follow the Irish IP framework, and do they comply with this?
So say, in terms of, it would depend on the different funding, the terms and conditions of the funding program. So say with EU projects, they're guided by the DESCA agreement, which sets out the IP terms of the collaboration in that sense. So while we have our national framework, we're kind of guided by the terms and conditions of the funder as well.
All right, okay.
Stacey, can I just ask for clarification, for projects that are 100% funded?
Yeah.
Would you get companies, let's say we want to own all the IP, is that one way of doing it?
The kind of the principal models is in terms of, so if it's 100% state funded, the intellectual property would reside within the university. If it's co-funded, the university would still own the IP, but the company would get an option to license that, and that option could be exclusive or non-exclusive. Also, there's provisions built in that if the company is bringing what we call significant background intellectual property, so intellectual property that's the subject of a patent, and the improvement that we make is a non-severable improvement, i.e. basically what we've done is improved the company's background, but we can't actually go and commercialize it ourselves without infringing their patent, then there is an ability to assign, but it is at fair market values, and that's because we're guided by the EU state aid rules. But like you've said, Sean, if a company pays 100% of the research, then the company has the option then to own that intellectual property.
Great, thanks, William.
Excellent. So thank you very much for your time and for the presentation, Stacey. We'll be moving on to our next speaker, Michelle Savian, talking about the life cycle assessment of agroforestry. All yours.
Hello, thank you for inviting me to this presentation. My name is Michelle Savian. I don't know, you are seeing the presentation, right?
Yeah, we can see the slides, but not in full screen view. Yeah.
Is it fine?
Perfect.
Okay. So I work with Platform 3 in BiOrbic, and my background is geology, and I did a specialization in life and environmental management system, and then a master in environmental technology, and now I'm doing my PhD in life cycle assessment. So I'm going to talk today about what is life cycle assessment, cradle to grave production system, why use life cycle assessment framework, LCA impact categories, environmental public declaration or EPD, agroforest system, and my case study in Brazil, that LCA of organic Tahiti lime, ginger, and hardwood production, LCA case study objective, the system diagram, environmental impacts that I'm going to analyze, and some expecting results. So LCA is a comprehensive tool to evaluate environmental impacts, is standardized by ISO 14040. And with this tool, you can measure and quantify a great amount of environmental impacts, like climate change, water quality, resource depletion, among others. So every product has a life. So we start with the design or development of the product, as for example, in research in university, followed by the research extraction to make the creation of the product, a production of the product, the use and consumption of this product, and finally the end of life. Yeah, that could be collecting and sorting, reuse, recycle, or the waste disposal. All activities in the product product's life result in environmental impacts due to the consumption of resource, emission of substance into the natural environment, or other environment exchange type of radiation. LCA is about estimation the magnitude of the consumption of the resource, emissions to the environment, and environment consequences. Why use LCA? The LCA is used for a variety of actors and stakeholders, helping to policy development, strategic decision-making, economic and marketing advantage, process improvement, legal compliance, hotspot identification, and scientific understanding. So I will give two examples of using LCA. So using LCA to an existing product to assess the baseline environment performance and efficiency of this product, establish the benchmark against which improvement can be measured, and making sure that that environmental impact are not shift from one area to the other. Another example is for a new product that may be helpful for designers to understand the potential environmental impact generated by their design options in terms of material, reduction of packaging, optimization of energy use and water, or elimination of use of toxic material. So this is the life cycle assessment framework based on the ISO 14040. So the life cycle assessment is made in 4 stages. The first is the goal and scope definition. In this stage, we define the purpose of the work, the study, the limit, the system boundary of the study, what are the environmental impact that is going to be analyzed, and who is going to use the results. The second stage is life cycle inventory, where all the input and output flows of the products are collected. For example, energy use, water consumption, raw material, different types of raw materials, and the energy use for any process. The third stage is the impact assessment, where we model the system in LCA software, and we analyze the impact that we define in the goal scope. And then we do the interpretation of the results, always focusing in the goal scope definition. So here is the impact category that is analyzed by the life cycle assessment. So here we have environmental interventions like raw material extractions, emissions to air, soil, and water, and the physical modification of natural areas like land conversion. The midpoint impact categories are climate change, resource depletions, land use, water use, human toxic effects, ozone depletion, photochemical ozone creation, ecotoxicity, eutrophication, acidification. Biodiversity, unfortunately, is not broadly used in life cycle assessment of food production. And this has an endpoint category that's human health, resource depletion, and ecosystem quality. Here is an example of environmental public declaration, is a good example of LCA. So environmental public declaration is a document that quantify and demonstrate the environmental impact of the product. They are environmental label or eco label, and the base of the environment product declaration is life cycle assessment. So I brought to you one example of the fresh organic egg production in Italy. So you have a global warming to produce 1 kilo of fresh eggs, around 18 eggs is 3.2 kilos of CO2 equivalent. If you take acidification potential, 60 grams of CO2 equivalent. And for example, water will be, I cannot see, but I think it's 1.2, if I'm not wrong, meters cubic of water consumption. So agroforestry system. So agroforest is the collective name for land use practice where trees are combined with crops and or animals on the same unit of land where there is a significant ecological and economic interactions between the trees and the agricultural component. There are 3 types of agroforestry systems: agro-silvicultural system that combine crops and tree, such as horticultural crops, or the one that I'm studying, that lime production; silvopastoral system that combines tree and pasturage with animals; and agro-silvopastoral systems that combine the 3 elements: animals, trees, and crops. So the case study, I'm working with the case study in Brazil. This is part of an international collaboration between BiOrbic and Rizoma Agro, which brings together organization, in this case academic and business, to share the value in context of sustainability. This collaborative partnership is aligned with SDG 17, is strengthening the means of development and revitalizing global partnership for sustainable development, and constitute a partnership of mutual benefits. In one side, the company, the Rizoma Agro, is having their products analyzed by the life cycle assessment. And for our sites, we have quality primary data, very important for us. So Rizoma Agro is the largest organic production in Brazil. They grow organic maize, organic soybeans, oat, beans, as well as egg production. And in the agroforestry system, they have the production of lime and the production of cattle or beef. So this is the design of the organic Tahiti lime production. So the lime is placed in lines with trees that can be as services trees and mahogany to produce hardwood. The distance between the lines is 5.5 meters, and the distance between the lime tree is around 2 meters. The density of the tree limes is similar to the conventional production, but in this case we have other products that is being producing in this unit area. That is ginger in the first and the second years of the system, the lime from the third to the 20 years. And by the end of the system, we have the wood tree, the mahogany, being produced for hardwood. So this is a picture taken around 2-3 years ago, where the trees, the lime trees, are not fully mature yet, so they didn't achieve the peak of the yield. And here we can see what we call service tree. They are normally part of the Atlantic forest, where this farm is located. And we have here the mahogany as well. So in between the lines, they cultivate green manure. This green manure is used in the central line as a complement to fertilize the soil. So the object of this study was agreed with the company, with Rizoma Agro, to assess the environmental impact of the organic lime, the ginger, and the hardwood production system in the agroforest system, comparing, contrasting the land use impact when the land cover is changed. For example, they have organic maize production, they want to change, and they already changed to lime production. So you want to see what is the difference in environmental impact, and how we can circulate byproducts and waste stream potential, as well as eco-efficient improvement of the system. So this is the system diagram of the lime production systems. So we start here with the nursery of the trees, and all the input data like fertilizers, water, electricity, and then we have the seeds, and then the trees are planting, and then you have every year the irrigation, the nutrition, the phytosanitary control of pests, and the pruning of the trees, and the weed control. So all the energy and materials of 20 years of production is being collected from the industry. So the function unit is 1 ton of lime, 1 ton of ginger, and 1 meter cubic of hardwood. So these are the impact categories we are studying: climate change, stratosphere ozone depletion, photochemical ozone formation, toxicity, terrestrial acidification, eutrophication, and water use, and non-renewable resource scarcity. All these impact categories is very common in life cycle assessment of food production. And the next one, biodiversity loss, SOC is soil organic carbon change, compactation of the soil, erosion resistance, mechanical filtration, physiochemical filtration, and groundwater regeneration, and biomass production is part of my PhD study. So I want to incorporate these environmental indicators into the LCA. So what we are expecting from the LCA results. So we are going to compare a conventional line with the agroforestry line, and probably you are going to find a smaller climate change impact, as well as ozone depletion, photochemical ozone formation, toxicity, especially because as an organic fertilizer, they don't use pesticides and herbicides, terrestrial acidification, eutrophication, water use, and non-renewable resource use. In terms of land cover change, when you change from organic maize to agroforest, we are expecting to see a decrease of biodiversity loss, an increase of soil organic carbon in the soil, a decrease of compactation of soil, an increase of erosion resistance, an increase of mechanical filtration, an increase of physiochemical filtration, an increase in groundwater regeneration, and an increase of biotic production. So these are the reference. Thank you. Any questions?
Thank you for this, Michelle. I'm going to start off with one question, maybe a little bit general, but we're focusing, or at least in Costa Rica, a lot of our focuses within the scope of the Biomaterials Hub is around biomass valorization, bioproducts, it could be bioplastics or biopackaging. Now, when a company is interested in getting into these new technologies, how could they, or when should they start implementing or looking at life cycle assessment? At any stage of their development process.
Yes, we can use life cycle assessment since the beginning of for example, a design of a project where we can compare different options, and see what is more eco-friendly. But you can analyze throughout the life cycle of the product. Could be an existing product, could be some alternative, for example, alternative of construction materials, or you could use LCA for part of your system. For example, what's the best manure management system, or what is the more eco-efficient manure management system. I hope I answer your question.
Okay, there's another question from the audience, is about the profit. Are the companies receiving more money by square meter with this mixing different products?
Yes, there is many advantages in producing in agroforest systems. One, that the systems is more resilient to climate change, for example, drought, and they receive more money for the products because they sell the lime, they sell the ginger, and in the end of the cycle, 20 years later, you can you sell the hard wood. And if you ask me, and how about the yield of this is comparison with the conventional, is practically the same yield. So is a very good advantage in terms of economics and in terms of environmental improvement of the soil and the land.
And another question, a follow-up question, is how do the company decide which products are able to mix it up? Can you hear me?
Sorry,
yes.
Jamie, broke up there a second.
All right. Yeah, there's a follow-up question asking, how do the companies decide which products are able to mix it up, and do you help them?
They have the design already ready when I start working with them. But for example, I'm working with them as well as in organic egg production. So in this case, for example, we are trying to see alternative to recirculate the nutrients that is generated by the farm. For example, using the wastewater from cleaning the bars, so they can reuse in other production systems that they have in the farm.
All right, thank you. That sounds like a very complex process, and yeah, good luck with the rest of your research.
Oh, thank you very much.
Now we'll be moving on to our last speaker from Ireland. This is a pre-recorded session because unfortunately, the speaker, James Gaffey, could not make it today. Sean, would you be presenting the video, or would it be
my understanding,
Jonathan
has the video. Yeah,
okay.
So Jonathan has it, so we'll be able
Jonathan,
to share screen.
Yeah.
Nope. Could you see the screen?
Yeah.
Okay, let's start.
We can't hear anything.
You'll need to reshare your screen and enable video sound, I think, when you're sharing, I think, if that's of any help.
Okay, thank you. Okay, so sorry I couldn't join you in real time. So I've been traveling when this event was scheduled to take place, but thanks to Sean and the BiOrbic team for the invitation to talk a little bit about the development of green biorefineries in Ireland. So I'm part of BiOrbic. I also co-direct a research group called CircBio at Munster Technological University, which is in the southwest of Ireland. So talking about the topic of green biorefineries, we have a recent paper which we've just published, which gives an overview of defining green biorefineries, taking through their history and evolution to different drivers that have resulted in the developments of the technology. Also looking at the different systems, the different feedstocks that can be used, and the different products that can be derived from them. So you can look at that in more detail. I'm going to focus in this presentation more on the Irish context for green biorefineries and some of the research that we've done in the area. So in terms of context, well, first of all, grasses and legumes are some of the primary production crops which can be used in green biorefineries, and some crop residues can be used as well. And from an Irish point of view, it's quite interesting. We're called the Emerald Isle. We have over 50% of our total land area, which is grassland. We're the only country in Europe that can say that. And about 90% of our agricultural land is grass. And we grow grass, you know, very in a very productive way. It's about a third higher than the European average in terms of productivity. So it's a key feedstock if we were to think about developing a bioeconomy in Ireland. And it's primarily used at the moment for livestock production. But that brings with it some challenges, because you can see on the left-hand side of the screen, it tells the story of herd numbers in Ireland over the last couple of decades, which have been continually on the rise. The introduction of milk quotas reduced the amount of dairy cows, but made a push for other cows. And then when dairy quotas were abolished in 2015, there's a surge now in dairy production. And overall, the trend is for higher herd numbers. And, you know, as a consequence of that, largely, Ireland's greenhouse gas emissions in agriculture, and because agriculture is such a dominant sector of the economy in Ireland, are particularly high. They're the highest in Europe. Around a third of our total greenhouse gas emissions are coming from agriculture. And if you look into the kind of makeup of those emissions, you can see that the majority of emissions are coming from the livestock sector and the pasture land sector, where you have enteric fermentation, which is methane production, which accounts for nearly 60% of total emissions, and then nitrous oxide from agricultural soils, from, for example, the spreading of fertilizers is the other big one at around 30%, as well as manure management at around 10%. So this is predominantly a livestock challenge from an Irish point of view. And it's resulting in sort of national challenges for farmers to try and help to resolve this crisis. And in 2022, there was a carbon budget agreed for all sectors to agree limits and reductions for each of the different main sectors of the economy to reduce emissions, with a 25% emission reduction target agreed in the agriculture sector for 2030. So this is a big challenge for agriculture. Another challenge that we face is around protein. So nationally, Ireland is a very dependent protein importer in terms of protein ingredients for animal feed. And we're much more dependent on imports than most of our European neighbours. we import about 3 million tons of protein ingredients annually. A lot of this is in the form of soybean meal, which is oftentimes very unsustainably sourced. So this has resulted in recent years in various fodder shortages happening. A particularly bad one happened in 2017, and then you have the Ukraine crisis over the last year, which has also placed tough scenarios on farmers in terms of accessing animal feed concentrates for example, dairy and beef production, but also for the pig and poultry sector as well. So it's a resilience challenge, but it's also a commercial challenge for farmers who are looking at exporting a high value product to international markets. And you have a number of retailers now taking a stand against dairy products, which, for example, integrate soybean within the mix, within the feed mix. And this is something that I'm already hearing back from pig and poultry farmers as being something that's just around the corner from their point of view as well. So it's something that Ireland really needs to come to terms with. And already there's a lot of work looking at alternative proteins, but I think green biorefinery is one avenue towards meeting this challenge, and I'll talk about that later. This is a small-scale green biorefinery, which we've demonstrated through initially in 2017 a project called Biorefinery Gloss, and we've done a lot of work looking at and evaluating products, but also immersing farmers in Ireland with the idea of green biorefineries. So this has been operational on their farms producing products, and then we've been testing the products and looking at the business model around these. And then we've done some more recent work in a project called Farm Zero C, where we've gone on to test the products further, and I'll talk about some new developments as well once we get to the end. So essentially what's happening here is you have fresh grass. Grass is essentially reduced in size. So there's a maceration step. There's a pressing step, which separates out the grass into a fiber fraction, which has about 30 to 40% dry matter, and protein juice, or green juice, which contains about 40% of the protein in grass, which can later be heated, and then the protein can actually be removed out from the rest of the juice, can be dried, can be used potentially as a feedstock for other animals who wouldn't be typically able to break down grass and extract the protein. So it's enabling or unlocking the protein for other uses, for monogastrics or for human use, for example. And later on, you can take the residual stream that's left, which is called a whey or a brown juice, and you can, it's got a lot of minerals, a lot of sugars, and that can be further valorized into different products. One of the interesting products we extracted from that was fructooligosaccharides, which can be used as a prebiotic. So it's a high value ingredient. And these are some of the different streams. So you have the green juice and the press cake, the fiber on top, which immediately comes out of the primary separation process. And then from the green juice, you can extract the gold colored material, which is the fructooligosaccharides concentrate, the light brown material, which is a leaf protein concentrate, which can be used as an animal feed, and the darker material, which is the grass whey or the defos whey, which can be used potentially for anaerobic digestion and used back within the process. So in terms of how green biorefineries can address some of the challenges that I mentioned, what's really nice and new about the work that's been conducted in recent years has been to look at how green biorefineries can optimize the overall protein efficiency of grass. And there are other avenues that we can look at, other material products we can look at, but specifically looking at protein and trying to address the challenges that I've mentioned. We explored the use of press cake silage as a feed source for dairy cows, trying to understand, well, if we extract out some of the protein in grass and then we take this press cake and feed it to cows, is it going to have a negative impact in terms of milk productivity, which we may expect it to have, especially when we consider that the press cake had, based on our analysis, about 10% of crude protein, whereas grass silage, which we compared it to, had 16% crude protein. So there's a significant difference. But what we found was when we included the press cake within a traditional dairy diet and we replaced 2/3 of the grass silage with this press cake, we found that while the overall protein levels were lower, based on, and this was quite a comprehensive trial, based on the trial feeding the dairy cows with this alternative diet, we found that much more of the nitrogen that was contained in the diet and protein was being converted into the product, which is the milk, and much less of it was being lost in the feces and urine when we compare it to the grass silage diet. So there's typically an oversupply of protein in the diet. A lot of this ends up leaving the animal in the form of waste. We're seeing a much more efficient process where even though the overall protein in the press cake is lower, because it's opened out more, it's more accessible, and it's being used at a higher efficiency by the cow to produce milk. And we're seeing less losses in terms of excrement as a consequence, which is an environmental benefit from the process. One of the early stage pieces of research we've done as well, and we're elaborating this further through a new paper as well, is looking at using an in vitro model, the impact that we could see on rumen methane production, which I mentioned is another big challenge that's associated with cattle production in Ireland. And what we found was that even though we tried this at different replacement rates, at the highest replacement rate, we could actually achieve about a 15% reduction in rumen methane in the case of cows on our press cake diet compared with a grass silage diet. So there's potential environmental benefits looking at this as an alternative feed for the cows. But then there's an additional environmental benefit if we can then take the remaining protein and extract that out and feed it to pigs and displace soybean meal, which is one of the things that we've been trying to do as well. As I mentioned, we import a lot of soybean meal into Ireland. It's the main staple form of protein within the pig diet. So what we're looking at here is trying to replace out soybean, all of the soybean or a certain portion of the soybean with this locally produced grass protein. And so we've had some really interesting results based on the work that we've done so far. We've been trying it in stages, so we haven't just gone straight for 100% replacement rate of the soybean meal because it could impact the pigs negatively. So we've tried it at various replacement rates. We've done 2 trials so far. So initially through the Biorefining Gloss project, we had a 27% replacement rate of soybean meal in traditional weaner diet. At that stage, we had a grass protein concentrate, which was about 34% crude protein. This compares with about 44 to 48% in the case of soybean meal. But what we actually found was at the 27% replacement rate, the pigs liked the protein, so the daily feed intake was higher. The feed conversion ratio was more or less the same as the control diet, and over the course of the trial we actually had pigs gaining more weight on this diet that included the grass protein concentrate at a 27% replacement rate. And in a recent trial, which we've done as part of the Farm Zero C project, the crude protein is actually higher. It's up around 43%, so it's much more comparable to crude protein. And so we've been able to include this at a rate of 50%. So this means that half of the protein that's soybean meal in the pig feed diet is taken out, replaced with grass-based protein, and we actually once again had a higher intake in the case of the treatment diet, similar feed conversion ratio, and an average daily gain that's slightly higher in the case of the pigs that are on the treatment diet compared with the control diet. So this is really promising in terms of showing how we could become more resilient from a national feeding point of view, and more sustainable as well through the reduction of imported feeds. And the farmers we're working with are already, giving very positive feedback to us in terms of the potential of this alternative feed. So in terms of diversification, I mentioned that there's the biomethane strategy that's coming up, and grass is one of the key feedstocks that we're looking at within this from a national point of view as a feedstock and a diversification opportunity. Some of the work we're looking at on the grass biorefinery or green biorefinery side is really showing that, we have a lot of potential to integrate this protein model alongside anaerobic digestion. We've done an analysis through this paper of various different streams that are coming off the grass biorefinery and looking at them as potential feedstocks for the production of biogas and biomethane, potentially using it back into the process. We're having very positive results. It's quite a high moisture content material. We're finding that based on some of the modeling work we've done, that about 80 to 90% of the energy requirements of the green biorefinery could actually be met simply by using this waste stream or byproduct as a source of feedstock for anaerobic digestion, and to integrate this model, and something we're looking at more at the moment for the next stage of this. How do we integrate this and scale this as an integrated model of anaerobic digestion with green biorefinery? But so far, it seems like promising feedstock for use back within the biorefinery. One of the more recent trials we've done has also looked at the impact of feeding soybean meal to pigs and then taking the slurry from pigs and using this as a source of feedstock for anaerobic digestion. It's particularly framed around the case study farmer that we've been working with to test this material, because he actually supplies most of his slurry to a community digester, which is co-owned by a number of actors within the area. We've actually found that there has been a significant increase in the case of biomethane production in the case of pigs fed with our grass protein diet versus pigs fed with our soybean only as the source of protein feed diet. So this is another potential avenue to improve the availability of renewable energy, and also to show how we can integrate this kind of model within the broader biomethane sector. So I think it's a huge opportunity to not just look at the production of biogas, but think how much protein we can produce, the different products as well we can produce. We can produce insulation material, we can produce paper. All of these products are possible looking at the production of grass. So it's really important, I think, to explore this as a kind of value-added opportunity which meets the needs of our future economy. I mentioned also about the inclusion of farmers. This is a paper by Kieran Harrahill, who looked at the model used within the grass biorefinery glass project, exploring the power and knowledge dynamics within that project. And as I mentioned, I think it's really important that there is this kind of model for bioeconomy which fully integrates farmers. And based on this study, it shows that there is a strong linkage from a project point of view in terms of the different actors that were participating in the project. And this is something we wanted to do. We didn't want to do a project which was tucked away in a lab and no one would be able to see it. We wanted to interact very much with the farmers, to share the knowledge with the farmers, to show how it could be implemented on farm. I think that's really important, because I think that brings the interest of other farmers. If farmers are very interested what other farmers are doing, and if they can see something operational in a farm setting, it's a really powerful vehicle for improving the level of interest and potential uptake of this type of model by the farmers. So I think this is a really important part of the work we've been doing. And I think also from a model point of view going forward, grass is quite a difficult feedstock in terms of mobilizing and scaling. It contains about over 80% water, so transporting it long distances isn't really a viable option. So I see this as being more of a local model. The technologies for this, at least the primary processing technologies, are quite simple. So I think that there's definitely a model there that can be developed for farmers to actually become part of the value creation within this model. So it's not all companies taking over, but it's more of a local model that farmers can be involved in, can create and share in the value that's created. And that's what I'd like to see, I think. So just to mention about the next steps, so we have recently received funding through the Department of Agriculture in infrastructure of just over €3 million, which is between UCD and MTU, working alongside Carberry, who are a dairy co-op and have been a very important partner in all of this, reaching down to the farmers, and the 4 West Cork cooperatives, including particularly the Barry Row Co-op, have been a brilliant partner for us as well. So we've just been awarded 3 million for an integrated green biorefinery and anaerobic digestion unit. So as I mentioned, this exploration of how we can co-produce products like protein, but maybe other products as well, alongside anaerobic digestion, is something that we're keen to explore, but to do it in a non-farm setting. So it's going to be based at Chinook Farm in Bandon in County Cork. So again, there's that model of being able to show farmers what's possible, which I think is a really important aspect of the bioeconomy if we want to get buy-in, if we want to scale up, and so on. So that's kind of an overview of what we've been doing. I mentioned a number of papers, and these are contained in the references, so you can download them and have a look further. And I'm very happy to receive any questions that come afterwards via email and so on. And I think there's my details, so if someone wants to make contact, you're very welcome to do so. So thanks very much for your time, and I'll give the floor back to the hosts, and bye-bye.
No, that was a really exciting presentation. I think there's a lot of overlap with what we can do in Costa Rica, especially considering pineapple waste and with working with sugarcane as well. Now, in the spirit of time, I'd like to press on and move to our Costa Rica speaker. So we have Alvaro Peralta talking on behalf of CR Biomed and UREC to discuss the industry opportunities in Costa Rica, what he's seen, and his and CR Biomed's perspective on this. All yours, Alvaro.
Thank you, Adam, and thank you to the speakers today. It's very exciting to see all that's happening in Ireland, and I see a lot of things that are common to the Costa Rican ecosystem in bioeconomy. So I'm going to talk about very quickly about 3 things today. One is about CR Biomed, just a quick overview of the cluster. Then we're going to talk about the CR bioeconomy ecosystem, and then like brief vision of the future and where we are heading as a country. So CR Biomed is the life sciences and biotechnology R&D cluster in Costa Rica. It was founded in 2016 officially, but we were working as a cluster sort of since 2012 or 2010. So we have been working at this for quite a while. So the main goal of CR Biomed is to articulate and to be a catalyst of the Costa Rica's biotech and life sciences R&D industries development and competitivity. So when we started working as a cluster, Costa Rica was in sort of a transition toward actually gaining an understanding that the bioeconomy had the potential of becoming a driver of the national economy and a source of income generation, of course, but also development in terms of employment, social justice, to bring better opportunities to areas that were in other ways struggling, in their economies and their job creations and whatnot. So we have participated as a cluster in public policy creation with the Costa Rican bioeconomy strategy. And now there's a circular economy strategy that's been worked on. We have been to a point consulting in this process as well, or participating in this process. And what's important about the cluster is that we integrate five sectors or the five sectors of the economy. So we have entrepreneurs in the cluster, also corporate or corporations, fund providers, venture capitalists, and also other fund sources. The government is a part of the cluster, and also academia. So we have been lucky to be supported by the government from Procomer and also MISIT, but also our organizations as CINDE have been instrumental for us as cluster to grow and to integrate more players, and also to have a better, larger impact in the local ecosystem. So to talk a little bit about the Costa Rican ecosystem and its strengths and challenges, where I want to focus today. I'm going to talk first about the strengths and opportunities that we have. So first of all, the people is one of the best and the most important assets the country has. So the country has invested for many years in education. We have great scientists, great scientific minds, and also we have the research centers and the installed capacity for those researchers to carry on their work. We also, as a country, have been working in public policy that's geared toward creating or facilitating the creation of value in the country through the bioeconomy and bioeconomy eventually companies. Also, Costa Rica is a large residual biomass generator. So, and this is coming mostly from agro-industrial activities. So in this sense, we are similar to Ireland. And my work specifically, besides CR Biomed as a company, we have a company that actually works in the valorization of residual biomass from agriculture and agricultural activities. And we have huge sources of residual biomass, such as, for example, the pineapple industry, which is generating close to 9 million tons of leaves and roots that are left on the field every year. We have industries you were talking about today, as for example, the egg production industry or the poultry industry in general. We have industries such as coffee and bananas. So all these agricultural activities generate quite a bit of residual biomass. And until very recently, I would say, 5 to 10 years ago, there was little research and little interest in creating solutions for that biomass to create value from that biomass. I am very happy because I see it with CR Biomed that there's a lot of new research going on, and there's people that have and scientists that have done very interesting research from some years back in these biomass sources, and to create potential valuable products from those, and also technology to process those biomass sources. There's something to be said about the biorefinery concept that James Gaffey was talking about earlier. And at some point, I think maybe most of us have thought about energy production and gas production from biomass. And of course, that's a first stage usually. But there's much more value to be extracted from those biomass sources. So a biorefinery concept is super important, and I think Costa Rica and the Costa Rican ecosystem is starting to grasp the value that could be unlocked through biorefining those biomass sources or materials. So that's very important as well. There's technology that's being developed in the country. There's also research projects that are being developed, and there are some projects that are now being, or that have come to a point to be scaled up industrially. So Costa Rica also has a large and diverse biodiversity. It's a country that it's very small. Geographically, we are 52,000 square kilometers. So that's a small country, and we have a diversity of climate and geographies that create a very rich biodiversity and ecosystems. So that creates a good opportunity for bioprospecting, and bioprospecting it's one of the key activities that the country should be looking at in a bioeconomy and with a bioeconomy mindset. We also have a strong social security system, and that means that we have a strong public healthcare system, which opens the door for clinical trials. And we have infrastructure even for preclinical trials that needs to be improved, but there's a very good opportunity there. So if you link everything that I'm saying together, we have people, we have research centers and installed capacity, we have bioeconomy and circular economy policies, we have large biomass producers, but residual biomass producers. We have a great biodiversity, and we are a very small country with a strong social security system and public health care that would eventually unlock the health and pharma side of the spectrum when we think about projects in that sense. So that all of that creates the opportunity of becoming a very interesting laboratory to develop technology and products, especially those related to the bioeconomy. So we have seen that there's two sources sources, I would say, of projects coming into the pipeline. One is organic, of course, researchers, local, international researchers that are coming to the country, entrepreneurs and companies that have needs, for example, to solve some sort of problem. And so that's generating projects, and those projects eventually could become companies. But there's also inorganic sources, for example, those created by public policy or motivated by public policy, and NGOs working to develop the local innovation ecosystem, especially in this bioeconomy setting. So, for example, the work that's been done by the Biomaterials Hub, it's very important because they are linking companies with potential solutions and creating challenges and calls to bring solutions to the table. So that's very important. Something that's being said in this by the speakers as well. It's I want to point it out is that it's very important to integrate not only the science side of things, but we need to integrate the industry. Both the producer of the biomass and also the markets need to come online to actually have a sense and develop things that are market oriented and that will create viable solutions. Some of the challenges that we are facing in the country are, I would say, structural in most cases. So we'll list them very quickly because I don't want to spend a lot of time here, but it's important for us to have a vision of some of the challenges that we're working on right now. So legislation and regulations, I think that's a challenge everywhere, but here in Costa Rica, we need to unlock the potential of clinical and preclinical trials. We also have to have a better, clearer, and more efficient way to access genetic material with, with the permits and the process that includes. We also need to improve product registration and to be more efficient at it. And with this, I'm not saying that we need to avoid regulation. What I'm saying is we need to have efficient regulation that will allow innovation to thrive. and to be able to register new products that comply, of course, with the regulation. But regulation shouldn't be an obstacle to innovation. We have a big issue now with public purchasing, especially for academia. So most of the R&D being done in the country comes from academia. So public purchasing becomes an issue when it, I would say, slows down innovation and R&D. So that's a matter that needs to be addressed. And linked to that, there's a matter of also solving a way to have better access to research materials, reagents and biological material to do research. So this is things that we as a cluster we are working on, but we are also connecting with government and institutions to bring solutions to the table and to not only propose the solutions but also to work on actually implementing those solutions. We have a lot of support from universities, for example, from Tech and UNA, Universidad Nacional, in these efforts to actually come up with solutions. Then there's a matter of public funding for bioeconomy projects, and that's money that needs to come into the early stages of these projects to unlock the potential that's there. There's also a matter of a challenge in the public-private collaboration and technology transfer side of things. So there needs to be more transparency in terms of the rules of engagement here. There's also need to be a better IP regulation understanding in the ecosystem, and also fund management, and that goes back to the public purchasing legislation. Finally, there's a need of industry-specific experience in funding, in regulation, in IP, and other things that need to be industry-specific. Finally, I want to talk. This is a very quick, like, graphic. I would say like a picture of the ecosystem. So in one side we have the innovation ecosystem that has support activities, public policy, academia, incubation, acceleration, government, and in the other side we have the industry and R&D per industry. So there's a lot of hype right now with new materials, bioinformatics, nanobiotech, but there's also a lot of things being done in food and nutraceutical industry and animal health, and also in education and human health and bioprospection. So today, this is how I see and how we see the Costa Rican ecosystem. It's a little bit linked, but these three large areas need to be much more in touch with each other. And this is important because with innovation, R&D, and markets, we can come up with very good solutions. So just to finish up, a quick word about the future. I see, and we see Costa Rica as I said, as a very interesting laboratory for bioeconomy, for the bioeconomy. We are a very small market in Costa Rica, so anything that's done here needs to think globally and to think global markets. But we have the biomass, we have the agricultural industry, we have a very good health system, public health system. We have the researchers and the installed capacities. So we can come up with solutions that can create technology and value in that, and value through that technology, intellectual property, and we can take that as a country, as an economy, to other countries. We can export, as a matter of saying, export that technology, that knowledge, those processes that can be developed in the country, and new products, and take those to global markets. That's a huge opportunity. There's a lot of challenges in the way that we have to overcome. And coming back to the talks from BiOrbic, which I think it's very, very interesting, because we're some years ahead of what we're doing right now in terms of connecting the environment and enabling the environment to innovate. these types of approaches and eventual collaborations with BiOrbic and with other countries as well, it's super important. We need to create more of these spaces and learn and collaborate for the future. So an invitation from CR Biomed to BiOrbic, it's, let's work together. Let's create some of these projects that you're working on in the biomasses that are logical for Ireland. We can bring some of those technologies here to Costa Rica. We can get projects going with you. And also we can take some of what we're doing here in Costa Rica and take it to Ireland and value those technologies and the potential of transferring those technologies there as well. So that's it from me, from CR Biomed. Thank you for your presentations and your time, and to CINDE and Nadim for organizing this space. And please, if there's any questions, I'll be happy to answer.
Thank you. Always great to hear your perspective, Alvaro. In the spirit of time, we want to move on to our last speaker, Eric Alvarado. He's a regional research coordinator at the National Technical University, and he'll be talking to us a little bit about the university industry linkages. So, all yours.
Okay. Hi. So happy to be here, and I'm going to talk to you about best practices in the collaboration between academy and industry. These are some examples of the 5 public universities we have in Costa Rica, and there are examples related with bioeconomy. The first example is about Universidad Técnica Nacional, UTN. This is a company called Nico Verde, which is a license for the transfer of social and environmental business models in the production of edible, medicinal, and biomaterial mushrooms from residual pineapple biomass. In this case, the university gives the license to Nico Verde company through our foundation, the Funda UTN, in the context of prototyped regenerative and solidary circular bioeconomy. Some challenges and opportunities which this experience are the capacity for the generation of documents and specialized consultation. In this case, external parties were used for confidentiality agreements, license contracts, and require addendums. And the second is this project. With this project, we could estimate the economic of the know-how in relation to the investment and corrective entries applied. And then the determination of the years of license was done based in economic indicators and the prediction of scenarios for the estimation of optimum bonus, which is the royalties. And the other challenge or opportunity was the incorporation of vulnerable groups in the chain of value in the innovation of the business model. This is important because this project, in this project are involved some groups of women and other vulnerable groups in rural areas in Costa Rica. Okay, the other example is from Tecnológico de Costa Rica, the TEC, and this is a company called Agrícola Pieces with the product Humitec Bioterra. This is a license for a procedure for the production of a powdered formula from the spores of mythosporic mushrooms for either radicular use or a soil inoculant. Here, the opportunity is the capacity to transfer applicable results from trichoderma, the fungus trichoderma formulation in crops with the purpose of reducing product loss in the post-harvest phase, the opportunity to identify needs in the productive sector and to have the capacity to provide technical and scientific solutions, and the creation of resources that are received by the university to support the corresponding school or career and the inventors too. So this is the example from the tech. The other example we have is from Universidad Nacional de Costa Rica, de UNA. This is a project called breast cancer screening. And here the medical system analyzes mammography images in DCOM format based on the breast imaging reporting and data system or BiRADS stage 4. This is a method of automatic identification that facilitates the detection of cancer based on the criteria of morphology, density, and distribution obtained from the analysis of medical images. Through the use of artificial intelligence for the interpretation of mammograms for preventive medical screening and prompt treatment. This is a project which has a business opportunity because the technology they have is available for licensing. So this is the example that the Universidad Nacional has. The other example is from Universidad de Costa Rica, UCR. The name is IVIG, human blood derivatives, which means intravenous immunoglobulin production. The example is based on the licensing of a patent provided in more than 20 territories, which allows to obtain simultaneously albumin and immunoglobulins with injectable quality. Its application is based on taking advantage or as much as possible of blood plasma or serum in order to obtain protein solutions. The license was given to a company from Colombia, which specializes in the treatment of complex and rare high-cost diseases. Some of the challenges of this project, challenges and opportunities are the main challenges were the management of the different applications in more than 12 country territories and in the negotiation of the license. The other opportunity is the important topic where maintenance of the patents in such territories and the calculation of bonuses as well as the payment installments. And the last one, it was difficult to reach an agreement about the implementation of the patent in the sense of the deadlines for the company to begin using the technology and its entry to the marketplace. This is the example from Universidad de Costa Rica. And the last example is from Universidad Estatal a Distancia, UNED. This is a project called SMATTER. You can see here in the image, this is a material which we can plant, and SMATTER is a project of inspired materials with mushroom mycelium for agricultural use. This project was carried out together with a group of students from the university, And the name of the project, which what I said is it was called Smarter, who already started their startup. So these are 5 projects we have in our universities, and that's all I have.
Thank you for sharing this, Eric. And yeah, there's a lot of opportunities available, and very exciting to see how we can collaborate closely with Ireland and BiOrbic and the institutions in Ireland for this academic industrial or even academic collaboration. Now, with that said, I'd like to thank you all for joining us today. It's been a very exciting, well, 2+ hours, and have a great evening, have a great day. And if you have any questions, any comments, any suggestions, any potential collaborative opportunities, feel free to email me or Sean. So we'll be sending out our contact details to all the registered participants. And we hope to see you at our next webinar session.